All right, so here we are at number 8, and the directions are to graph the inequality. And the inequality they've given us is x plus y is less than negative 6. And you'll recall that with inequalities, when we're graphing inequalities, we're going to be shading on one side of the line or the other based upon a test point that we're going to choose towards the end. So not only do we know we're going to be shading with this particular problem, but because it's an inequality, we have to remember what type of line we're going to use to actually sketch the graph. And so when you're dealing with a less than or greater than, don't forget that your line is going to be dotted or dashed. And when you're dealing with a less than or equal to or greater than or equal to, you're going to be dealing with a solid line. And so in this case, we know that because this is simply a less than, we're going to be plotting a dotted or dashed line. All right, so now that we've kind of reviewed those two important aspects of an inequality, let's go ahead and actually get this, let's go ahead and actually sketch the graph. So we've been given, again, x plus y less than negative 6. And the way that we graph an inequality is the same way that we graph a regular linear equation. So just like number 1, we can either choose to solve for the x and y intercepts here, or what we can do is simply put this into y equals mx plus b. And I think that's probably going to be the easier of the two solutions. So let's go ahead and just subtract x from both sides. And when we do that, we're left with y is less than negative x minus 6. And so here we have our inequality in y equals mx plus b. And this now we can easily graph. We're going to go to negative 6 is our b. That's our y-intercept. So negative 1, negative 2, 3, 4, negative 5, negative 6. We're going to plot that point. And then we're going to use our slope, which in this case is negative 1, right? The coefficient of the x is your slope. And we're going to use this slope, which is, of course, rise over run, to plot our next point. So because our rise, or numerator, is negative, instead of going up, we're actually going to fall 1 unit and then run to the right unit, to the right 1 unit rather. So fall 1, run 1. Put our dot, our point. And now that we have 2 points on our graph, we can go ahead and connect these 2 points and have ourselves a line. And again, let's just make sure that we're using that dotted or dashed line because of our inequality. So we'll go ahead and something looks like that. Of course, if you had a ruler, that would look a little better, but we'll go ahead and call that good for now. All right, so now that we've actually put our, we've sketched our graph, let's go ahead and decide which side of the line we're going to be shading on. Are we going to be shading above the line or below the line? And just like I referenced to earlier in the video, we're going to use what's known as a test point to tell us which side of the line to shade on. If your line, if your graph does not go through the origin 0, 0, use the test point 0, 0, because the origin is the easiest point to work with. If your line does go through 0, 0, use an equally easy point to work with, like 1, 1, or negative 1, negative 1, or something like that. So you could choose any point in the world to be your test point, so long as that point does not lie on your actual graph. In this case, we can clearly see that the origin 0, 0 is not on this graph, so let's go ahead and use the test point 0, 0. So this is our x, this is our y, and of course we're going to take our test point, plug it back into the original inequality. We could plug it back into the manipulated inequality if we want to, but I always like going back to the original, just in case. And we're going to, when we plug our test point in, see if we get a true statement. So let's go ahead and plug 0 in for x, 0 in for y at the same time, and evaluate. So we're going to plug 0 in for x, plus 0 for y is less than negative 6. Well, here on the left, we have 0 plus 0. Well, that's just 0 is less than negative 6. Is this a true statement? Is the number 0 less than or smaller than negative 6? Well, no, it's not, right? This is a false statement. And so because the point that we chose was above the line, and we ended up with a false statement when we plugged in that point, that means any point above this line will also give us a false statement. So we want to shade on the opposite side because we want to shade where the points make our inequality true. All right, so again, you always shade on the side of the line where if you were to take a point from that side, plug it into your inequality, you're looking to get a true statement. And we can go ahead and test that. Let's go ahead and let me choose a different color so we can see. Let's go ahead and choose a point that is clearly not on this line. So let's choose -10, -10 right here. So let's go ahead and choose that as a test point. You don't have to do more than one test point. As soon as you test one and you get a true or false statement, you know, but just for the purposes of illustrating why we're shading below the line here, we're going to test -10, -10. This is our x, this is our y. We're going to plug this point into the original inequality at the same time. So we had x plus y was less than -6. Let's go ahead and plug in. So we have -10 and then plus -10 less than -6. Well, here we have -10 now minus -10, or just -10 is less than -6. Well, -10 minus 10 is -20, is less than -6. Is -20 less than -6? Yes, it is. That's a true statement. And so again, because if this was the original point that we had chose, because that point, the red point, is below our dotted blue line, and we got a true statement, that means every single point below this line will also give us a true statement. And we always, always want to shade where the points make your inequality true. All right, so again, here's our line, and we're going to shade below the line for number 8.